Okay, this is about manipulating reactions, adding reactions, and how do I get K's from that. So there's two main rules for this. If you add two reactions together, then you multiply their K's. And if you reverse reaction, then K reverse equal 1 over KF. Those are really the only two rules you need to know. Okay, so we're going to try to come up with reactions from reactions we already have. I'm going to use this rule to explain a little bit about what we know about acids. For example, we know this reaction, F minus plus H2O, that's a weak base, weak acid reaction. You should immediately recognize this. And we have conjugate acid-base pairs here and here. Okay, and so we can get the K from this. And we know KW equal KA times KB. We know this from freshman chemistry. I'm going to explain why it works now. To figure this out, the only K I really have is KA. I have that. And so if I write my reactions down and add them up together, I should be able to come up with the reaction that works, that gives me this and will allow me to get KB from KW and KA. So to do this, what I'm going to do is reverse my reaction that I know. So I know this reaction right here. I know this one, HF plus H2O in equilibrium to give me H3O plus F minus. So if I take this reaction and I flip it, I get F minus plus H3O plus in equilibrium with HF plus H2O. Now, I know the K's for these, okay? This K for this original reaction is Ka, and I can look that up. I can look up Ka for HF. It is 6.8 times 10 to the minus 4. Good enough. Now, what I have here for this reaction, the F minus and the H3O plus, is I actually have the reverse reaction. So I'm going to label this reaction 1, and that is K1 is equal to 1 over Ka by rule number 2 up above. Now what I do, I want to get rid of this water, move it over here, and get rid of this H3O plus. So how do I do that? I use the water-water reaction. H2O plus H2O gives me H3O plus OH minus. Now watch carefully how I do this. I'm going to add these two reactions. This is rule 1. I'm adding reactions, so I'm going to multiply K's. The K for this second reaction, K2, is equal to KW. And I can treat this as an equal sign. So if I total them all up, I get this total reaction. Here we go. I get F minus plus H3O plus 2 waters in equilibrium with HF plus H2O plus H3O plus OH minus. Okay, and I can do some canceling. Let's cancel a water here and get rid of that. And I can cancel an H3O plus and H3O plus. So my final reaction, F minus plus one of these waters, H2O, is in equilibrium with HF plus OH minus. Exactly what I wanted. Let me move the screen. Okay, so now I go back and I do my K's. K for this is K1 times K2, which is equal to, K2 is on the top because it's KW, so I'll put a KW there, and K1 is 1 over Ka, and so I get Ka there. This is 1 times 10 to the minus 14th divided by 6.8 times 10 to the minus 4, and that gives me 1.47 times 10 to the minus 11. So that's how I manipulate Kas. I'm going to do another problem here. Okay, so let's look at a slightly more complicated system, a diprotic system. So here's a diprotic acid. You may or may not be familiar with them. H2C2O4 plus water is in equilibrium with HC2O4 minus plus H3O plus. I have a Ka for this. Ka1 is equal to 5.62 times 10 to the minus 2. And then HC2O4 minus plus water can go on to react to give us the oxalate base. And that's Ka2. And that equal 5.42 times 10 to the minus 4th. So that's the system I'm working with. So let's put a double line in here, because the problem I'm going to ask now is I want the Kb for the oxalate ion. So for example, if I gave you Na2C2O4, I would hope you'd immediately recognize that that's a one-way arrow. There's no equilibrium, and I get 2 sodium plus C2O4 minus 2, and then this goes on to react. So what I want to do is I know the reaction, I want to find the K for it. C2O4 minus 2 plus water gives me HC2O4 minus plus OH minus. I want to find the K for that reaction. K equal. So I'm going to use my reactions above here and start again with that. So I need this and this, and water, of course, in OH minus. But what I look at the reactions I have right here C2O4 minus 2 and HC2O4. Okay, so I can use that reaction. I think that's going to get me somewhere, so I try it. So I start here, C2O4 minus 2 plus H3O plus. I'm using reaction, I should label reaction 2 up above. Okay, I'm using this reaction, and I reversed it. But how did I know to reverse it? Well, I looked here and I said, oh, C2O4 minus 2 is on that side, and C2O4 minus 2 is on this side on the right, so I'm going to reverse it, try to get what I want. Never know if it's going to work out. Sometimes you have to try a couple times. And that K for this reaction, and I'll call this reaction A. That's probably going to be a mistake. K, capital A, is equal to 1 over Ka2. Now this is the first base reaction because it's completely basic. It'll react from here to here, and then it'll go onward to H2C2O4, so that would be a second base system. So we're not going to go that far. So that gets me pretty close. All I got to do now is react with the water and get rid of the water on both sides. H2O plus H2O gives me H3O plus OH minus, and that is K reaction B. Reaction B is equal to KW. And when I add them now, I get, well, water cancels here and here, H3O plus, and I get C2O4 minus 2 plus water in equilibrium with HC2O4 minus plus OH minus. That's exactly what I want. And the K for this, let me slide this up a little bit. So the K for this is going to be K equal K capital A times K capital B, which is 1 over Ka2 times Kw, which Ka2 was equal to let's see, this will be 1 times 10 to the minus 14th for kW divided by 5.42 times 10 to the minus 4th, which gives us a value of 1.84 times 10 to the minus 11. Okay, so now this K here is called KB1. So what I recognize, and that's because it's the first base reaction, I get C2O4 minus 2 going to HC2O4. That's the first basic reaction, HC2O4 minus, and then that goes to H2C2O4, and that's the second one. So it turns out that KB1, the first basic reaction from this thing, is equal to 1 over K2, or KW divided by Ka2, excuse me. And in general, KB2 will be equal to KW divided by Ka1. Okay? So there you go, manipulating them. Now I'll do another video with more complicated